Exercise 7, which of the following describes the chi-squared distribution? When you picture chi-squared, you should picture a very right-skewed distribution. The tail is on the right. And so A. Of course, as the degrees of freedom go up, then this thing actually looks more and more normal. But the best description here is going to be right-skewed. It's always right-skewed a little bit. As you increase your sample size, humongous, then it begins to look more and more normal. Okay, exercise 8, we've got a two-way table. We're asked to work out some chi-squared information. Many of you will see problems like this in your biology classes. It's very common to do chi-squared there. So what I want you to see is I've gone ahead and given you the totals, the column totals, the row totals, the table total. You may or may not have those. If you don't have these, you'll need to compute them yourself. But this table is a mirror image of this table, just blanked out. And we want to get the expected value. Here's the observed value. What's the expected value right there? And the way that you do it is, for this blank, you go back up to the observed value, and you just find the row total times the column total. You multiply those, and then you divide by the table total. So this number is 100 times 130 over 200. And when you compute that, you're going to get 65. And I'll do one more. So for this spot, I'm looking here at the 20, and I take row total times column total, so 100 times 40 over 200, and you're going to get 20. And so we'll just fill in the rest. So you'll get 15 here, 65, 20, and 15. So if you have any difficulties, right, maybe stop it there and get those correct. To compute the chi-squared test statistic, you take your observed value, subtract the expected value, and then square that divided by the expected value, add them all up. So let's write it out together. So 60 minus 65, that's 60 subtract 65, square the difference, and then divide by the expected value of 65. The next one, I get 20 minus 20. That's just 0, so the whole thing zeroes out. I'll put a 0 there. The next one, I get 20 minus 15. I'm going to square that, and I'm going to divide by 15. Now I'm down here, 70 minus 65. I'm writing it all out. Of course, you could actually just say, well, that's just 5, and 5 squared is 25. Well, whatever. Put this over 65. I'm going to have to go down. 20 minus 20 is 0 again, so we'll put a plus 0 there. And then we get a 10 minus 15 squared over 15. Add everything up, and you will get 4.1022. So that's the chi-square statistic. You'll certainly need to be able to compute that for our final exam. What degrees of freedom do you use? So in this case, for the chi-squared distribution, you're going to take the number of rows minus 1 times the number of columns minus 1. And so there are 2 rows, so 2 minus 1 times the number of columns. 3 columns, subtract 1, and you end up with 1 times 2, which is just 2.